You know that moment when you are coding and something goes wrong? What do? Do you immediately open the debugger and methodically trace through the problem? Of course not. You start scratching print statements everywhere, here, there, everywhere, and keep running your program until you finally understand what's broken. We have all done it. It works, it's messy, but it gets the job done. But here's the thing. When you push your application to production, you can't do that anymore. You can't just add print statement and sit there watching your terminal. Your app is running on servers you might not even have direct access to, serving hundreds or thousands of users. Yet, you still need to know what's happening. Is something going wrong at the runtime? Is a critical section of your code performing poorly? Is there security vulnerability being exploited right now? Are users hitting errors you never anticipated? This is exactly where logs come in. Logs are your application flight recorder. A program could crash. To know why, you should see the history as the flight recorder does when a plane crashes to know where the problem was. An engine, some technical things in the wings, etc. The same as in your app. You go to the critical places in your code, the places that matter for performance, security, or reliability, and you tell your application to record what's happening there. Save it to a file, track it, monitor it. In essence, logs are just a way to monitor your application at runtime, to get an overview of what's happening, to track performance and security, and to understand your application behavior when you are not watching. It's debugging for production. Keep along because we're gonna start to deep dive into logs. Let's start with an easy example. Web applications are one of the most common places where you will see logs in action, and one of the most famous use cases, login HTTP request. Let me show you. I have a sample file here called index.html. To serve it, I'll run python 3-m http.server. This starts a lightweight web server on port 8000. Notice the server is listening on 0.0.0.0. That means it is accessible from any network interface, not secure if you don't want this to be accessed outside your PC. So if you are not in an isolated environment, I recommend to add --bind localhost. Now, let's visit this page. I'll open my browser and enter the loopback address. There we go. The page loads. And look at the terminal. We got a new line. So this is the IP address where the request comes from. As you can see that indeed we requested from the local host, or after name resolution it is the address 127.0.0.1. We have two values that are not available for us for now and are represented by two dashes. This is the timestamp of when the request happened. The HTTP method, in this case it is get. The path request, in this case it is slash, and the protocol version. And finally 200. This is the statute code. 200 means it is success. Now, watch what happens when I request a path that doesn't exist, like slash test 123. I get another line, but this time with a 404 statute code, indicating the page wasn't found. These lines, they are logs. But wait, I can't just leave a terminal open and scroll through it every time I want to check my logs. Like if I had hundreds of requests, that's not practical. Let's save them to a file instead. In this case, these logs are being written to the std error, which is the stream too. If you are not familiar with streams, I recommend watching my previous video where I deep dive into stdin, stdout, and stderr to redirect stderr to a file we use to greater than. So we will add it to our command. Now, when I start the server and make a request, nothing appears in the terminal. But look, a file called requests.log was created. And if we check inside, there is our log entry. We just built our own logging system. Now, if someone tries injecting payloads into our URL paths, we can catch them, block their IP, or take whatever action we need. But here's the thing, if you are testing something, running command cat every time gets frustrating fast. Let's show you a command you will use all the time, especially when we start building security projects in future videos. It's called tail. Tail is like cat, but it only shows the end of a file. You can specify how many lines with -n, like tail-n5, and the name of the file gets us the last 5 lines. But here's the real magic. The flag -f, which means follow, this lets you watch the file in real time. When I make a new request, boom, the log appear instantly. And when I press Ctrl C to exit, the logs are still safely saved in the file. There is another command called head that shows the top of a file, but we won't need it for now. Now, most applications save their logs in a similar way. Some use the same streams, others add new ones, but here's the key. Log files shouldn't just be stored anywhere. There's a proper place for them. Typically, logs should live in /var/log with a proper file name matching the application, or sometimes in a dedicated folder like /var/log in the name of the app. And here is something critical. Logs should have proper access permission. They should only be accessible by the application itself and by users in a group that meant to have access to that app in its logs. Also, no critical information should be stored there as they are counted as not safe. This is a secure measure. Let's look at a practical example. Apache. Apache is the default web server on many Linux distributions. Let's examine how it handles login. Apache login files are stored at /var/log/apache2. Let's access that folder. See those store important files, access.log and error.log. These serve the same exact purpose we talked about earlier. Access.log contains information about request and response, who is visiting your site, what pages they are requesting, status code, response size, and in the other hand, there is error.log, capture errors that occur while the server is running. Things like PHP errors, configuration issues, or internal server problems. Remember how we said logs are defined using streams? Let's see what Apache is exactly doing under the hood. But before, let's try with our Python web server. Let's run our command and add ampersand at the end and see the streams. Here you go. The stream 2 is forwarded to that file. The same as Apache, we should find Apache process ID first. Let's run this command and get the PID. Now let's look at its file descriptor. Look at that. We have got some interesting streams here. File descriptor 2 is pointing to error.log. File descriptor 8 is pointing to access.log. And there are other streams for different purposes. Of course, there is 3 standard streams, stdin, stdout, and stderror. But you can add custom streams as we have in this case. Apache is doing exactly what we did earlier, redirecting output to log files, but it's doing it programmatically and managing multiple streams for different type of information. This is standard practice for production applications. They manage their own log streams, store them in organized locations, and set proper permission to keep them secure. In the next video, we'll explore how to configure these logs, rotate them to save disk space, and use them for real monitoring and security analysis. See you in the next one. Bye bye.